Hi, everybody. You hear me okay? Good, okay. So I go into social situations sometimes, and people ask me, what do I do? And I say, I work with AI. And it's pretty much a conversation killer. They kind of go away and say, oh, very smart, and I don't think I can talk at your level. And I'm not really a smart one. Now, Dr. Mohammed Ahmed is the really smart one because he creates solutions with AI, but I implement it. And that's a different thing. AI has made my life easier. My teams can implement things that we could not conceive of doing 5, 10 years ago, and now we can. And so that's the difference there. And so when I talk about AI and that I'm involved with it, I maybe pretend that I'm smarter than I am. So let me tell you the story. I worked with the U.S. Army Logistics Support Activity in Huntsville, Alabama for 3 years. And we have a large program there. We manage a data center, which, by the way, gets more hits in a day than the U.S. Stock Exchange. And because it's got all the logistics data in the Army there. And so as part of that program, we manage that, and we provide a lot of other IT-type services to that group. And I managed all the enterprise architecture, business analytics, business intelligence, data warehouse, all that kind of stuff, really all the fun stuff, in my opinion, on that project. And so 2 years ago, Allison came to Huntsville and did a demo about predictive maintenance for printers. And I had the LOGSA senior leadership team take a look at this, and we started talking about how could this apply to Army equipment? And so over the course of the next year, we kept batting that around and trying different things, and we finally decided to do a proof of concept. And we focused, and I think if you were in the general session this morning, you heard General Hicks talk about the Stryker combat vehicle as being the most advanced. It fights in a different way. It's heavily instrumented. It's the new type of ground combat system for the Army. And so we decided that's what we would focus on because we had data. We had sensor data. We had maintenance data. We had 15 years. Well, actually, the Army had 3 years of maintenance data, but the OEM, bless their hearts, gave us 12. So we had data that we could work with. We had the availability of subject matter experts, both at LOGSA and with other folks around the Army Research Lab in Pennsylvania, TACOM up in Warren, Michigan. We had a lot of folks that we could draw on and that we did draw on to be able to do a proof of concept. So we took those 15 years of maintenance work history, that 15-year set, and we took a look at what components are the biggest problem. And we came up with 5 components out of that we thought were statistically significant that we would want to try to drive at. And then we did an analysis to figure out how long do those components last on average. Just no other special information, no mission information, just on average, how long does an engine last? And we did this for engines, transmissions, suspension, steering, and fuel systems. So we did all that. And then we took about 6 months worth of sensor data, which is 5 billion readings off those vehicles, 5 billion readings. And we overlaid that information with our statistical analysis of all those sensor readings. So we were able to then look at the health of the vehicle and predict which components were going to fail in the next 30 days. So we did that. While we were doing that, we got 8,000 pages of documentation around those vehicles. 10 years of PS Magazine articles. If you're in the Army, you know what PS Magazine is. It's a graphic novel, illustrated maintenance best practices. It's really wonderful, great content. And but we also had maintenance manuals and safety of use messages and a variety of things. We ingested all of that into Watson taught it the context of what those documents were talking about, what the vehicles were, what Army terminology is, and then we wrote an application that took those predictions, showed it up on a nice dashboard, and then allowed you to drill down to the vehicle and to the component and see what the prediction is for that particular component, and then pull up the correct, relevant documentation to support a maintenance course of action. So that's what we did. And I have a pad out in the hallway out here where I can go into much more detail on that, and I can talk to anybody that's interested in talking about that. But the other piece of information you need to know is that we did that in 3 months, start to finish. And we did not have the maintenance data already in. We did have the sensor data. And so here's what we got out of that. First of all, everybody has bad data. And in this case, the data was very problematic for a variety of reasons. 2 different maintenance systems where they were using different identifiers for components and parts, et cetera. No bill of material of the vehicle itself that was in an electronic form. The sensor data was in tens of thousands of text, comma delimited files that every once in a while changed format without warning. So when we talk about, and Allison and Luke were talking a little bit about, a crisis every day. My analytics experts, as we were ingesting this information in, had a crisis every other day. And you just tackle each problem as it comes up and you get to where you need to be. So the point of all that was we could take a lot of information, a lot of not very pretty data that isn't integrated together today, isn't used for this purpose today, and we could use it and derive insights that you don't have today. And we showed for a Stryker brigade that about 38% of that brigade had a looming problem that the commander did not know about. And how much is that worth to a commander to know that information ahead of time and be able to do something about it? And that's the key. No prediction ever saved anybody's money or improved anybody's readiness. No prediction ever did that. What does that is the action taken. And by being able to advise on the action taken and bring immediate documentation support that's relevant to that particular problem, we have the opportunity to put information in the hands of people in a much faster, more efficient, more correct manner than ever before. So, okay, that's great. We can take all this information, but then I have people come to me and say, but I don't have all that. I don't have 15 years of maintenance history, or I don't have sensors on my equipment. So, I don't think I can do this. Maybe I just need to go work on all of that for the time being. But we say, well, let's look at how other organizations are addressing that very problem. So there's another organization that I can't mention out there that took that issue, and they had a large, extremely complex piece of equipment, many of them, and they would write up a report of all the problems that they had on that equipment and all the things they did about it by hand and turn that in every month. So a large set of these. So none of that information was coded in a system anywhere. It was all written by hand. So what did we do? We ingested all of that into Watson. Then we applied OCR technology to it. So we did optical character recognition. So we actually converted it into text. We then re-ingested it into Watson and taught Watson what it meant. And we started getting insights across this set of equipment, set of complex equipment. Started getting insights on what are the problem areas. Across the board, what types of components are giving us problems? What are we doing about it? How does that vary from one piece of equipment, one asset to another? Which assets are the biggest problem areas for us? So it's an example where we took something that was impossible to work with and so much information that human maintenance engineers couldn't absorb it all and make sense of it. And we made sense of it. And we gave it back to them. And what that does, so that has a couple different effects. First of all, people start to understand the power of the data that's already in your organization that you're just not tapping into. All right, so they understand that. And then they also understand that you could start anywhere with any kind of data to start tackling these problems. And then thirdly, in my mind, is once you start that process, it creates a demand for more data or for better data governance in our systems to make this easier to ingest or make the answers come out better and better. So it creates demand. So back to the Army, the Stryker proof of concept that we talked about. When we were looking at all this sensor data, and it was really hard to pull it all together and ingest it all, and we had to do all this work with it to clean it up. Well, that's because nobody ever tried to do what we were doing. Nobody was mining that data. So nobody really saw a need to go and require better data governance, better ways of sending that data in, better ways of collecting it automatically and bringing it in. But now there's a demand for that. And so now people are starting to realize, hey, we could get so much more if we take these particular actions. So again, we're not only talking about how to provide an advisor for actions in the field, for maintenance actions, but it's also giving you advice on systemic actions that you can take to get even better clarity on the readiness of your equipment. All right, so that is my story. And again, I'm out in the hall. I'm here till 3:30. Happy to have any discussions with anybody and go into more detail. But now I'd like to introduce my colleague, Dr. Mohammed Ahmed, and take it away.
Yeah. Hello, everyone. I'm Mohammed Ahmed. I lead a team in IBM that focuses on the application of AI and machine learning in different fields. So we try to apply it in the computer vision area. We try to apply it in understanding natural language. And I wanted to share with you in this few minutes some of the applications in computer vision and in text analytics. So the first application that I would like to share with you is an application that we built for NGA. And the application is called VERA. It stands for Video Exploration and Recognition Advisor. So NGA is faced with a problem that they are collecting a massive amount of videos coming from overhead imagery, different sensors, and it requires analysts to be able to look at these videos, look at these hours of videos, and try to detect if there is something relevant or important in these videos and write a report about it. So we talked with NGA that wouldn't it be nice that if we have a tool that look at this hours and hours of videos and would be able to detect objects in these videos and to alert an analyst whenever something relevant happening, rather than him spending 15 hours on a video is going to spend maybe half an hour. So we're cutting the workload of an analyst by almost 90%. So we worked with NGA to look at their data, and we built a pilot to look at a subset of the objects that they are interested in. So we use deep learning and machine learning to train a deep learning model to be able to detect cars. So we focus on cars at the beginning, whether it's a sedan, whether it's a truck, whether it's other type of cars. And also they were interested in showing me if there is any activity, anything changing in the video that I'm looking at. Maybe somebody is leaving a building, somebody is getting into his car, anything that doesn't have a model, but it's a change in the scene. And I want to be alerted. Whether it's important or not, let me decide about that. So these are the type of activities that we trained our deep learning system to be able to detect. So let me show you quickly an example. So these are some of the videos that already have been processed. Of course, I'm not sharing the actual classified videos. These are just public videos, but this will give you an idea of the capability, what it can do. So the analyst can have some information about the videos, where it has been taken, what is the lengths, the frame per second, and so on. But let's say I'm clicking on one of these videos. So this is it's type of a surveillance camera, and it's looking at an intersection, and we're running our model to be able to detect the objects that I mentioned. So you see here, it's near real time. It's able to detect every color is a type of object. So we have either it's a sedan, pickup, or other type of cars. If there is any activity. So sometimes you see this purple block. It indicates that something is changing. Maybe somebody is crossing the street, or the camera. Actually, we have another model for if the camera is completely moving in the scene. And we have this what's called the heartbeat. So you can, an analyst can look at this video, and looking at the bottom of the screen, you can see where exactly the activities are happening. And you can, by just a click of a mouse, that you can jump into this area of the video. If these objects, and they are, have GPS geolocation information, it's going to be highlighted on the map here. So let me show an example how this, maybe this is too busy, but this is an example where we're looking just at, I'm not looking at objects, I'm looking at just an activity, anything changing in the scene. So for this, the length of this video, you can see from this, what we call the heartbeat at the bottom, that there were some activities at the beginning, and then here, you don't have anything happening, right? And then something is happening at the end here. So rather than spending all your attention on this, I don't know, 15 hours of videos, then you can just jump to where interesting things is happening. So if I click here, then a car is approaching. And the height of this heartbeat actually tells you how many activities that we detected. Let's say I'm not interested in that, but I am interested in something happening here. What's happening here? So yeah, so there is a person now crossing the street, and so on. So again, think of an analyst. This really let him focus on the important stuff in the video, and whether it's a post-processing action, so we take the video after it had been collected, or we can also do it in real time. We also, so for this, let's say, for this particular video, let's say he is looking at the results, and we are detecting some of the objects here, but he thinks that maybe we missed some of the objects. So we give him the ability also to highlight part of the video and say, no, this is supposed to be a vehicle, you missed that, or this label is not an activity, and so on. And we can take this feedback and retrain our model. So over time, it gets better. The other thing that we do also is to produce a report. So again, this is just some statistics about the object that has been detected in this video, when they happened, and we can do some correlation between these different objects. Vera can be accessed. You can use the UI to visualize your data, or it can be accessed through an API. So let's say you have another application that can take advantage of Vera. You call the API, they get the results, and use it in another application. So this is how you can integrate it with other applications. Of course, we give the analyst the ability to upload a new video. So you can upload, let's say you have a new video coming, you can select what type of models that you want to run. And also, we give him the ability to search. So searching, you can use the map. I want just to focus on a certain area, bounded by a geo box, or start date, end date, what objects I'm looking at. You can also search using natural language. And I'm going to talk about another application of using AI to understand natural language. But we use this tool here to be able to ask questions about, show me video clips where there is a white sedan between this time frame and this time frame, and so on. So we successfully completed a pilot with NGA. They are very happy about the results. Actually, the results on the classified data is much more impressive than this. And we're moving into, hopefully, the next phase, expanding the number of objects, expanding the activities. And also, we are trying to integrate some of our research in what we call action classification. So it's good that we detect that there is an activity, but exactly what it is. We want to classify the action as, this is somebody leaving a backpack behind, or somebody entering the building, or leaving the building. 4 people are exiting from a car, and so on. So you can classify the action rather than just saying something happened. Okay, so this is one application of AI that my team has developed over the last 6 months. And it has been trained on the actual NGA data. The second application is application of AI on textual information. And I wanted to share with you, so Alison actually mentioned this, that we worked with one of the IC organizations to be able to look at the authenticity of news. It's a lofty goal to be able to detect if this is authentic news or not, is it fake or not. But we are trying to take steps towards this goal. So one of the steps is if we can detect the provenance and lineage of information. If you have a piece of information, let's say you have a post on Twitter, we want to highlight when was the earliest mention of the same, not exactly the same tweet, but the same topic that this tweet is talking about. So not word for word, but the same idea of the tweet, the same topic, the same context. So if you go back to the source, and now you can classify, you can rank the source as either trustworthy or not, then you can somehow, you will be able to determine if this is authentic news or not. So in order to do this, we use another of our tools. It's called BlueTask for social media analysis. So BlueTask actually you can ingest data from multiple data sources, whether it's Twitter, YouTube, Instagram, public Facebook, or we can also integrate some of, let's say we have a data aggregator, he is collecting his data, as long as he is exposing an API, Twitter, about Syria. Okay, so let's say you gathered this data, then what can you do with it? One is where if you are interested in a certain user, whether it's, there are so many applications about this. Maybe it's insider threat, or the Department of State about people traveling for or applying for a visa application. They want to look at the social media activity, we can build a profile of this user or this person. So what we do is we look at his tweets. For every tweet, we detect the language, we translate it to English if it's not English, we detect the sentiment, and also we build a network of association of this person with other people. Who is he retweeting? Who is he connected to? So you can build this type of network connection. Then using this information, I'm going very fast, but I'm going to be here after if you have any questions. Using this information, we have a machine learning model that can predict what we called an alert score, a warning score about a particular person. So we take into account what are the words that he's using, the mentions, the sentiment, what is the alert score of his network. We combine all of this into a score, and now it's up to whoever the analyst maybe to pay more attention to this application or not. So there are so many applications to this, but this alert score actually can be customized to any other application. So now let's go to what can we do with this tool. So if we're looking in general, I'm looking at, I'm searching Twitter now for North Korea. So these are people actually tweeting about this topic right now, and I'm pulling this information every 15 seconds. So again, we're building this, we're detecting, as I said, the language, the sentiment, and also we're building the connection between people talking on social media, the sentiment over time. So we use this with this Intel client to be able to giving a piece, a Twitter post, what is the earliest mention of this topic in Twitter? And we had several use cases. I'm not going to go into them, but this will give you the earliest mention of a certain post. And if you can relate it, of course, if you know the source, you can rank the source, and you can label it as trustworthy or not. We analyze the text, the textual content, but we also analyze the images. So people now are posting more and more images, so we want to tag them. And if people post these images with text in them, and actually people are using this more and more because you have a limited number of characters that you can use on Twitter, so you can actually post an image with a full page of information of text. So if you're just analyzing the textual content, you're going to miss the whole message. So we run what's called OCR in the wild, is just grabbing text from images, and we make it searchable. And finally is, I'm not sure if I can find it here, but we also have a machine learning, oh yeah, I found it. So you see this red and green little robots here. So actually, this is a model that gives you a probability that this is a fake account. And this is a machine-generated account, not, it's not belonging to a human. And again, so if you trace your information back to a machine-generated account, then again, you know what, if you can trust it or not. So this is a nutshell what we're doing for social media, and of course it has lots of applications. I'm not sure if I have time for another application. I know that I'm standing between you and lunch, but I can. Okay. So the third application is understanding natural language and building virtual agents. So, and we have seen this if you are following Watson Conversation and Watson Assistant, that you can use this technology now to build a chatbot that can interact in natural language, understand the intent from your question, and respond appropriately. And you can use it whether to respond to FAQ type questions, or you can use it to fulfill a business transaction. So let's say I want to chat with a chatbot. I want to update my account. I want to get information from my account. I want to pay. So you can. It's not just asking for information, but you can complete a transaction. So one interesting. So when you try to apply this, the problem would be: is your data secure or not? Of course, using a public cloud, your data, there is a risk because you're sending your data to a public cloud, and this poses a risk, and many organizations, they don't want to do that. That's why we built this virtual assistant. We call it Carla, and Carla actually can be deployed. It's a complete framework for building these chatbots and can be completely deployed on-prem. So it has access to all your data. You don't have to worry about any sending your data outside the organization, and you can build very smart chatbot that can understand intents, and it can learn continuously with interaction. So this is deployed currently with many. We have different pilots here in the US and overseas that with clients that have this data requirement, the privacy requirement. We have examples here. We work with FEMA, with United Way, with other, actually in the commercial sector, also banking. You would imagine that they care about their data. They don't want to send it to a public cloud. That's why they use this application. So just a couple of minutes, I can share with you a video of this FEMA disaster recovery application that we have built.
The best way to show you what Carla can do is to look at an example. So I'm going to take you through a chatbot that we've built for FEMA, the Federal Emergency Management Agency. With the recent hurricanes, there is a huge increase in the number of people applying for disaster assistance, and they have a lot of questions about the process. Currently, if a disaster survivor has a question about their application, they have to call FEMA and wait on hold for as long as 4 hours to speak to a representative. That sounds terrible. So we've built this chatbot using Carla to help mitigate that high call volume. So here's the situation. Lots of people have been calling in asking questions about where they can stay while their home is being repaired. So I'm going to pretend that I'm a disaster survivor and I'm looking for a hotel. Now there are a lot of ways I can ask my question. So let's start general and see if Carla can pick up my question and give me the answer I need. So here we are on the FEMA website. I'm going to open the chat function. And here's Carla. She says, "Welcome to the FEMA helpline. How can I help you today?" I'm going to say, "I need a place to stay." Carla comes back and says, "I'm sorry to hear you've been displaced. I understand you're looking for accommodation. Are you looking for hotels or shelters?" And I'm looking for a hotel. Great. In which state are you looking? I'm looking in Texas. So Carla's come back with the exact answer I need. Here is a list of participating FEMA evacuee hotels for Texas. I click on the link, and right here in the chatbot, Carla has pulled in information, actually through an existing API, with my specific answers to my question. So these are only Texas hotels, which is great. And it even has a whole bunch of information about whether pets are allowed, if there's a kitchen, and everything. So great. Asking my general question, I got the answer I needed. Now let's say I already know I need a hotel. I already know I need it in Texas. I don't need to go through this whole rigmarole of, do you want a shelter? What state are you in? So I could also ask my question another way. I could say, find me a hotel in Texas. So Carla comes back immediately with the answer that I need, right? She doesn't ask me follow-up questions. She doesn't take me around in circles. She knows exactly what I need and gets me the answer I want. But really what I'm looking for is which ones are available, not which ones exist. So I'm going to ask a follow-up question. I'm going to say, how do I know which ones have availability? So notice I have spelled availability wrong. Carla comes back and says, unfortunately, I'm not able to provide information about hotel availability. How else can I assist you? So Carla recognized that I was still asking a follow-up question to this hotel question and was able to follow the flow of thought.
Okay, so probably you got the idea. So So I have, different use cases for a registered user who is asking about shelters, about when an inspector going to be coming, insurance information, and so on. And actually, this is very helpful because during, after a disaster, we had some information that people who are staying on the phone for hours just to answer very simple questions. This technology, it can be used again for an end user asking about help, or for internal employees about maybe their benefits, asking about a career advice, and also it can be used to control an application. So something like Vera that I demoed. So you can control the whole application using voice-enabled functionality and using natural language. Well, so these are just three of the stuff that I wanted to share with you today, and I will be here if you have any questions. Thank you very much.
Okay, sorry to go long. The next event is lunch in the atrium. It goes till